Hello everyone. Welcome to new set of videos on wind energy systems. So in this series of videos I'm going to speak about what is the wind energy and what is the scenario around the world, and also we'll also see some kind of mathematical modeling of wind energy system and so on. So let's get started with this new series of videos. So in this introduction to wind energy systems. So wind power is not new. It has been used for pumping water from well or grinding grain or even for sailing ships. This is for many centuries. Wind energy has been used by the human beings. So you might search for old ships. Every ship had that wind sail where the wind power is actually running the ships, and ships used to travel for days and months together using this wind energy. When we say wind energy, ultimately all these energies come from sun. So ultimate source of energy, so is actually sun. So how the wind is getting the energy? So because sun is heating the planet Earth, at different places the heat is received differently. There is a temperature difference, and the temperature difference will bring about high pressure and low pressure. So sun and then causes temperature difference on Earth, and then causes different pressures. So there is a high pressure area and then low pressure area. So the wind flows from high pressure area to low pressure areas and so on. So this way the wind moves, and when the wind moves, so there is a mass and then it is moving. So any moving object with mass will have kinetic energy. So that kinetic energy we are trying to convert. So wind power is the extraction of power from the airflow using turbines. So we will actually see more details about that in the coming part of this video. And the power extracted P is proportional to cube of velocity of the wind. So let me write it. Power is proportional to cube of wind velocity. So this is one of the fundamental physical characteristics of wind energy system. So the one of the parameters we are looking at is the speed of wind. Now, by the way, so you can also look at pressure and density and all. But then, since we are talking about the outdoor installation of a wind system, so this atmospheric pressure is kind of more or less same everywhere. So the only changing factor or changing variable is the wind velocity. So and wind velocity cube is nothing but what is creating the power. That means doubling the wind speed causes 8 times energy increase in the output power. So and then if the wind velocity becomes half, the power becomes 1 by 8 times. So highly sensitive to variations in wind velocity. Now how do you perceive this wind velocity? Imagine you are standing on top of a building, and then you can see when the wind comes, when the breeze comes, it hits your face. You can actually feel the velocity on your face. So sometimes when there is a gentle breeze, you feel very pleasant and nice. So maybe that is a case where the wind velocity is, let's say, 2 meters per second. And then later when you actually travel in a on a bike, or you travel in a vehicle, and then the wind hits your face, that might be much faster. So maybe even 10 meters per second, or whatever. So here it is a 5 times increase in the velocity of the wind when you're just standing on a place with a gentle breeze, and then when you're moving on the vehicle. So what would the power? So because this is 5 times more, the power that is hitting your face would be actually cube of this 5. So it will be 1 is to 125. So 125 cube is 5 into 5 into 5. So it is 125. So you're actually getting 125 times that of the power that is there on when you compare 2 meters and 10 meters. So it is highly sensitive. So I've just given only an example. If you feel, since you might have that physical experience of breeze hitting your face, and then that's why this example I had given. But then it is highly sensitive to velocity of the wind. So sometimes wind velocity, if you see, if wind blows constantly, the output power would be constant. But then the moment there is a variation in the wind, so the variation in the output is the one of the problems. So anyway, here we are talking about advantages, but then when you come to disadvantages, the first disadvantage is the variable. So if I, on the x-axis, if I take time, and then this is a wind velocity. So let's say the wind velocity is normally 5, and then there is some variations like this in the wind velocity. So the variations in the power would be much more amplified. So it will be like very much amplified compared to the. So this is power output. So whereas the earlier one was the wind velocity. So this is one problem with the wind. So anyway, we'll come to that. So let's first look at the advantages of wind power. First is alternative to fossil fuel. So instead of using fossil fuel, now we are using wind, which is already it is a better proposition if you see. So especially if you consider some remote regions. So let's say in a remote place there is no connection to grid. So diesel generators are being used, which is highly polluting. So you can use the alternative, and then it is renewable energy. Wind is distributed, wind is plentiful. So it is not that wind is available only at a particular place, wind is available everywhere, and it is plentiful, and it doesn't consume water. So if you compare with solar, solar is also renewable and distributed whatever, but then solar panels, they get dusty, and you need to from time to time wash the panels with water, and it requires some water consumption and all. But whereas this wind turbines doesn't require water, so that's another advantage. Produces no greenhouse gases, uses little land. So again, you see, compared to land usage, so this is much less land usage, because this is just a land, and then you have only one large tower, and then you have this windmill here. So this is the windmill. So the land, only the where this base is there, that much only land is being used. So the remaining land, you can do agriculture, you can do any other work for there. Net effect on environment is minimal. So these are the advantages of the wind power. While because of these advantages, the wind power is prominent. In fact, compared to solar, wind is more popular compared to solar. And then already we had seen in this video, in this series of lectures, that solar itself is being very highly increasing. So the same logic or same argument also happens to wind power. Given these advantages, wind power is really, really significantly picking up around the world. So we're going to see that also. So let's continue. So what are the disadvantages of wind power? So of course it is variable, it is non-dispatchable. So what is meaning of non-dispatchable? Dispatch means you are able to specify that at this particular time this much should be the power. So this is time versus power generation. So at time 10 o'clock, 10:15 or 10:30. So every 15 minutes I can specify that you can generate 100 megawatts or 110 megawatt or 80 megawatt or 75 megawatt. So we can specify what is the power at what time. So this is nothing but a dispatch. So who creates this dispatch is the system operator creates this dispatch. So but then I don't know how much this table may be true for a coal power plant, or even a coal power is not a renewable energy. But coming to renewable energy, hydropower plant is a renewable energy. So such kind of a table can be defined a priori for a. So this is a dispatch table. Such a table can be defined for a dispatchable generator, but wind power is non-dispatchable. What is the meaning? Meaning is I cannot tell beforehand what is going to be the power generation. At 10 o'clock, I don't know. At 10:15, I don't know. 10:30, 10:45, I don't know how much power is going to be generated at any time. And and as we just now discussed, what is going to happen? Depending on the wind velocity. So maybe wind velocity as 10:15 is 8 meters per second. So the power may be 80 megawatts. and wind velocity at 1030 may fall to 4 meters per second. So wind has become half, so power will become one eighth because it's a power of cube, so it will become only 10 megawatt. So that way, huge variations can be expected in the power generation in the wind. But there are different ways to address this intermittency. It's also called intermittent. So sudden reduction, sudden increase, things are like. There are different ways to address this. First of all, you can choose a proper site where there is not much of variation in the wind. So, for example, if you talk about offshore wind power, that means it is not on the shore; it is off the shore. That means it is in the water. So, if you have a wind turbine, this is land, but instead of land, if you have water, and in the water, if you set up a wind tower, then because there are no obstructions, the wind velocity variation will be very minimal, and therefore power will be very stable, and even the wind will be more than the this thing. So in the land, there you can find trees, you can find hills, you can find buildings and all, which will obstruct the wind and which will disturb the wind pattern. But if you are talking about a ocean, on the ocean there are no uh, buildings or anything, so therefore the wind will be very constant and very stable. We'll see such things later. So another disadvantage is challenges for stability. So of course the stability of the transmission system is also under question. We'll come to that. So capacity factor is low, 10 to 20% capacity factor. So what is the meaning of this capacity factor is, in fact, again, we have a specific full calculation about this capacity factor later in this video. So what we mean by capacity factor is, let's say I install a wind turbine and somebody says the capacity of this is 1 megawatt. So this 1 megawatt, the wind, it operates, it's a capacity, but it doesn't mean it's generating 1 megawatt. So sometimes there is high wind, sometimes there is low wind. So if I operate for 10 hours, ideally so 1 megawatt into 10 hours, I should get 10 megawatt hours of energy. That is the ideal case. But practically, I might get only 2 megawatt hour. And this ratio 2 by 10 is actually the capacity factor, and that capacity factor is this one. So not just over period of 10 hours, but if you take it over a period of 1 month or 1 year, so around the year, all the time full capacity the machine may not be working because of the less wind. So it sometimes very high wind is there, so therefore the capacity factor can be calculated that way. Actual energy generated divided by theoretically how much energy you can generate. So that ratio is the capacity factor. 10 to 20%, that is again another disadvantage. So for example, if you want to compare what is the capacity factor of a thermal plant. So thermal plant capacity factor is almost close to 95%. 90 to 95% you will have the, so where that 5% or 10% is lost is only when you purposefully shut down the thermal generator to repair or maintenance or whatever. Otherwise a thermal plant will, all the time you can operate it, you can feed in as much coal you want, and then according to the rating of course, and then you can generate the power. So so look at the difference in the capacity factor. So 1 megawatt thermal plant will generate much more energy compared to 1 megawatt wind power. So, but then what is the advantage? So, here the fuel cost will be there. Here the running cost is almost zero. So you don't have to do anything. Just wait for the wind to come, and the moment wind blows, your turbine rotates and generates energy. There is no fuel cost with the wind power. Uh, so speaking of that, so let's look at the wind turbine construction working principle. So you have this land, and then land or water, whatever, and then you have some tower like this, and on top of this tower there is this kind of a structure. I think this is called nacelle, and inside that there will be gears. So this is gears, this is brakes, and this is the generator. So this is generator, this may be brakes, this may be a gear system, and then this is connected to the. Of course, I'm drawing very small. Actually, the wind blades will be much bigger. I'm just drawing smaller wind blades just for this. So here the wind is blowing, and then this will rotate, and then this gear wheel will rotate. There is a shaft, and then this is generating power. So first thing you should know in the working principle is that the direction of the wind turbine is not fixed. So it's compared with the sunflower. So the you have the sunflower. So when the sun is here in the morning, the sunflower will be facing towards the sun. And you notice when in the evening when the sun goes to the other side, then even the sunflower also rotates, and then it always faces the sun. So that is why it is called sunflower. So just like how a sunflower all the time faces the sun, the wind turbine also designed in such a way all the time it faces the wind. So you might say, what happens if the wind is coming from this side? So this thing here, there is a entire mechanism here which can rotate, and then this is anyway fixed. The pole is anyway fixed. This thing will rotate, and then this whole thing will face towards the wind. So all the time there is a sensor somewhere at the back. There is a something called anemometer, which measures the wind velocity, wind direction, everything, and depending on that, it gives command to this particular system. It always so all the time this this wind turbine faces opposite to the flow of the wind. So that is one thing. So another thing is there is something called a pitch control. So what is pitch control is if you look at the blade of the wind turbine, the blade cross section will be something like this. So uh, just like the cross section of a aeroplane wing, so it will be like this. So this is the entire length of the blade. So this is the cross section. So now if I face this blade perpendicular to the wind, then the forces on this blade will be more severe. So there is always some angle theta or the pitch angle. So that happens. So if there is a small angle like this, and then the wind is coming like this, then this wind will push this way, and then it starts rotating. So that way that angle is there. So the more angle is there, the more push will come and more it will rotate. But then it cannot be completely parallel. So if the wind is coming like this, although your entire turbine is facing the wind, but your cross section of your blade is also parallel to the wind direction, then there won't be any much of the force on the wind turbine. Therefore, so through this pitch control, I can control how much the wind can hit the blades. Now, another example is you can actually look at a fan. So in your house or wherever you can find, if there is a fan, the fan blades are not flat. There is some small angle for the fan blade. So if this is the fan, so there is always some angle that is there. So by the way, fan is nothing but the opposite of wind power generation, because fan generates air. So in your room, it gives you air and it inputs so this is the fan. So what is the input? Input is electricity, and the output is your air in your room. So similarly, the opposite is wind turbine. So input is air, and then the output is electricity. So this is one of the fun things with the now construction and working principle. I think I might have a picture. So yeah, so this is the picture. So I found this picture somewhere in the internet. So you can actually also search and find something. So as I said, this is the blade. You see the shape of the blade. It is something like this, and this is the tower, and then this yaw motor it is called. Yaw is the technical word for the like how sunflower it faces all the time the wind. So it is like this. So look at the top. Wind direction is this way. So exactly parallel to the wind direction is your shaft of your generator. So this red one is the generator, and the anemometer I was saying. So this is the what measures the speed of the wind and direction of the wind, and this will control the entire thing. High speed shaft nacelle. all these things, and then pitch control. So by rotating this, I can control the pitch of the blade, and by controlling the pitch of the blade, I can control the amount of power that is generated. So also you might look at this figure. So here, what this shows is uh, what is the in the market, what is the highest capacity wind availability. So in 1990s, half megawatt was the wind tower, 40 meters. So but as people started, there is a market started increasing and people started producing more and more. By the time 2015, we are having a 10 megawatt. So one single tower itself can generate a 10 megawatt of power. Now, so you see, this is 145 meters is the diameter of the whole thing. So diameter of this entire what is called is the area of contact. So the surface area of the wind turbine. And here the diameter is 126 meters. Here the diameter is 120 meters and all. So as you see, as the diameter is reducing, the power is also reducing. So the power generated is also proportional to the diameter of the rotor. Now, one thing you notice, let's say I want to generate 10 megawatt. So in 2015, I want to generate 10 megawatts power. So I will buy only this one tower. But let's say in 2000, let's say in 1995, or why just take 15 years back. In the year of 2000, I want to generate 10 megawatts. So at that time, I have to purchase. See, in the market, what is available? The biggest size is only 2 megawatt. So I have to purchase 5 of this particular thing, these towers. So the 5 of these towers, the 880 meters is the area. So it will, first of all, 5 towers will cost more. Of course, the height is less, but still, buying 5 towers will cost more, and then 80 meters diameter, and then it's going to generate that much. And now imagine in 10 years back again, in 1990, I want to generate 10 megawatts. So what is happening? So each one will generate only zero point 0.5 megawatts. So I have to purchase 20 towers like this, 40 meters height. So 20 towers will occupy a lot of place. So now you see what is happening. The technology is developing, and as the technology developing, more and more bigger sized wind turbines are becoming available. People are manufacturing bigger turbines, and just by one big turbine, we are able to solve the problem, and we are able to get the 10 megawatts in just one turbine. So, so this would be cheaper. Like for the same amount of power, in 2015, it is cheaper compared to the earlier years. You can actually see it here physically in this plot. So, the ability to to manufacture a very large wind turbine is also making it cheaper. Now, another thing is that now what is happening is the problem is now transportation is becoming the problem. So let's say there is a site and then there is a manufacturing plant. So you can manufacture a blade, and the blade itself is, let's say, now here what is a 70 meters is a blade. So imagine what is 70 meters. So 70 meters is almost like a 30-story building. I don't know. I mean, if I consider one floor is 2 meters, so it's or maybe 20 to 25 stories building. So that this itself is that building. So such is the size of the meters now. So in fact, wind turbines will see that. So I hope you're getting some sense of scale, sense of idea about what is this wind turbine and how it is. Of course, we will separately see another video which is looking at the mathematical working of this wind power and all. So let's continue. Now, what kind of generator we use? So this is just again a small thing. So there's a generator here. Just now the generator is converting electrical energy to mechanical energy to electrical energy. Now the thing is, since the wind is variable, I cannot use a synchronous generator. So whereas in the thermal power plant, I can use a synchronous generator because there is a steam turbine and there is a fixed amount of steam I can send it, and then I can run the turbine at a constant speed, and I can maintain the frequency, and I can generate the power. That's not a problem. Whereas here the problem is the wind itself is variable. So sometimes there is a sudden rush of wind and it rotates very fast, and sometimes the wind is slow and then it rotates slow. So irrespective of the speed here, uh, of course the speed itself is varying. So what is the best generator for variable speed? So that is called induction generator. So you might have heard about induction motor. So induction motor and induction generator, basically they are one and the same, just the torques are different. So you know that synchronous motor all the time rotates at a synchronous speed, whereas induction motor has a concept of slip. So the same concept of slip also applies to induction generator. Here, the you can say slip is negative, and induction generator runs at super synchronous speed. So that means induction generator is a generator which is where the rotor is rotating faster than the stator magnetic field. Rotor rotates faster than stator. So I think if I draw the characteristics, it is something like this. So okay, so it will be something like this. So on the x-axis, this is the x-axis is the speed of the machine, and therefore this is the synchronous speed ns, and on the y-axis is the torque generated. So here the speed is 0, and here the speed equal to ns, n equal to ns, and this part is the motor. In fact, more specifically, this region is the motor region, that is induction motor, and this region is the induction generator. And you can notice the torque is negative, or actually it is producing torque. So anyway, I just want to mention that since the variable speed is there, so it is variable speed. Since the feature of variable speed is there with the induction generator, we are using this induction generator which is running at the super synchronous speed. Now the thing is, induction generator outputs active power P, but it consumes Q. So although your P it is generating, it is consuming Q. So that means you have this induction generator. So it is supplying P, but it is consuming Q. Therefore, this Q has to come from somewhere. So there is a local capacitor bank, and then that is there. So specifically, if you visit any wind plant, and in the wind plant, you can notice that if there is a substation nearby to the wind plant, you can also find the capacitor banks there. So those capacitor banks will give locally reactive power to the induction generators that are there in the wind turbine. So in your future, whoever is watching this video, so in your future, if you visit any wind tower plant or wind farm or anything, and you make a visit, and I also strongly recommend you to really make a visit. Actually, these wind turbine systems are really really huge. We always look at them from far and we think that it's a windmill. What is special about it? But when you actually stand near the turbine, when you actually touch it, you feel the size. It's huge. The blade itself is like a big building, and then you feel how much powerful it is, and so on. By the way, I just got diverted again. So what I'm saying is, when you visit such a wind farm, you can ask the people who are operating that wind farm, where are the capacitor banks? Like that, you can ask an intelligent question, and then suddenly, they will understand that, all right, this is a wind plant, and the induction generator is there, and it consumes reactive power. So we have to, somewhere locally there is a substation where you are integrating with the larger grid, and there you are connecting a capacitor banks. So you can ask such an intelligent question, and sometimes there could be even more intelligent answer to that question. So some of the newer technologies actually not using induction generator. There are some kind of special power electronic interfaces using which you are able to handle the variable speed then and there itself through power electronic controllers. Therefore, you might not require a capacitor bank. So if you are really going for a very advanced modern generation plant, uh, they might answer saying that we don't need a capacitor bank, something like that. But anyway, it doesn't harm in asking such a question. Still an intelligent question, so you can ask that. All right. So we are talking about a one individual turbine. But what is a wind farm? So wind farm is a multiple turbines, collection of many individual wind turbines which are interconnected. Onshore wind farms, so wind farms on the land, and offshore wind farms on the ocean. All these things. So, but then the ocean wind farms are expensive. Advantage is they are steady and strong. Strong power output is going to come. Whereas the wind farms on land are inexpensive, but there is a problem with the variability of the power. Now, layout of the wind farm in the so basically what happens is, if you have a large geographical area, so let's say this is an island, and all side there's a water, and this is the land, and then typically most of the time wind direction is like this. Then first you will see at the edge of the island, you'll see some towers like this. One, two. So this is a tower. This is another tower. By the way, when you are, this is also another interesting thing. When you can see the wind towers when you are actually in a flight, and through the window of the flight you can actually see these wind turbines. It is also a very nice view to see when your flight is going above some island like this, and it has wind power. If you get a chance in future, please remember that, remember to have a look outside. So your co-passenger may ask, what are you seeing? So you say, I'm trying to look at wind turbines, something like that. Anyway, so this is one row of wind turbine. So the distance between one and the other is 3 to 5 times direction perpendicular to direction of wind, and whereas 5 to 9 times you have another row of wind turbines like this. Sorry, my blades are very awfully bent, but then we'll actually see. So I'm writing search for photos of wind farms. We'll actually see some actual wind farms, and then we'll see. I think I'll do it right away. In fact, all this information that I am providing to you, I found from Wikipedia. There is a page on wind energy. So let me see if that page is still open. Yeah, here it is. So if I slightly pull this down, so you can see it is Wikipedia wind power. So you can see right away there's a picture of a wind farm. So here is the one, and then there are a lot of wind farms, wind generating turbines below. And if I go almost to the end, I think there are some pictures. So here you can see, wind turbines on this is called offshore wind turbines. So you can see here how they are generating power and so on. So anyway, I encourage you to actually go online and then search for some pictures of this. Okay, let's continue. So I mentioned wind power variations, highly intermittent in shorter time scales. Variations are consistent over the year. So if you look at over the minutes or over the hours or something, over the seasons and months, there is a variation. But then if you look at over 1 year, the pattern is more or less same. So that's again another slight advantage. Wind power is often paired with other forms of power. So that is also there. Let's continue. So now I mentioned there's a variabilities. So what are the power management techniques? Okay. So these are techniques to address variability of wind. So this becomes important. So first is have excess capacity. So therefore, although you have a wind generation here, so let's say this is here you have a wind generation. So some other place in your entire area, you can have some kind of hydropower or a thermal power or coal power plant, whatever. So you notice there is a fall in the wind, you can pick up the hydro. You can, if there is a high wind is there, you can reduce the hydro and such kind of thing. So have an excess capacity available. Then geographically distributed wind farms. So this is also one interesting way. So the wind variations, like if you concentrate all your wind turbines in only one place, then in one city, for example, then all of them will experience fall in the wind speed at the same. So, but then if you diversify them, so city A, city B, like this, so all of them are receiving some wind in different directions. So, on an average over the entire group, the variations can be reduced. We can have dispatchable backup sources, sufficient hydroelectric power, also export import of power from neighboring regions. So you can have a neighboring region and some transmission line is there. So the moment your wind is lost, you can ask power to come from the neighboring regions. Vehicle to grid strategy is another area. It's also a research area. It's also called V2G. So you have a lot of electric vehicles with storage capacity. So at the time when wind is excess, you can charge all the cars and keep the batteries charged. And when the wind is reduced, you can have some kind of a communication infrastructure to all the vehicles, requesting the vehicles to release power into the grid. And such kind of systems can be there. So that's called vehicle to grid strategy. In fact, that is again a deep subject. So demand response itself is again another area of research where you are asking the demand to respond to the supply. It is not that like in the earlier case, the supply used to respond to the demand. So the factory is starting at 10 o'clock. Therefore, you are prepared. At 10 o'clock, huge amount of load is going to come because the factory is starting. So the power operator will make a note of the demand, and then at 10 o'clock they switch on the generator. So now the reverse is there. So now the factory will ask at what time should is the power available. You say okay, wind power is available from 11 o'clock. Then they can start the factory at 11 o'clock and use the power and all. So where the demand is looking at the supply side and the demand is changing, that concept is called demand response. The way I put it, it might appear very odd, and why should the factory adjust? Why should the demand adjust to the supply? But then with proper incentive schemes and all, if not the entire 100% of the demand, there are certain demands which can be shifted. So, for example, you can washing of clothes can be a variable kind of shiftable kind of a load. There are certain loads which can be shifted throughout the day. So for that we can apply some incentive and some kind of demand response scheme. So again, this is again one of the power management technique to handle the variations. Weather forecasting to predict variations in the wind velocity. So forecasting anyway, it's a highly theoretical mathematical subject, and lot of value is there in forecasting things. So forecasting the weather, forecasting the wind, a lot of supercomputers are used, and then some forecasts are there. But still, the error might be as high as 15 to 20% error in the prediction of the wind. So if the wind velocity is predicted with 20% error, that might result in maybe even 60% variation in the power because it's a power of 3. whatever. So I might be a little bit wrong in my numbers here, but then you know that wind power output is highly sensitive to the wind velocity. So anyway, these are some power management techniques. Let's continue. Let's look at world scenario of wind power. So again, as I said, this is the source of my information that I am telling now. So generally the statistics. So of course nobody has to remember all these statistics, but then it also helps if you get the general sense of the idea of the statistics. I'm not saying that everybody should remember everything, but then as we know, like the normal heartbeat is such and such range, the normal blood pressure is such and such range, normal body temperature is such and such range. Like these are the important things, whether because they know whether it is normal or not. So similarly, this is the thing. So global, so some general numbers you should know, so that you can suddenly say if some politician makes a statement that we are going to install this much of gigawatts by this much year, you can actually make sense whether it is a promise is achievable or not achievable, or feasible or not feasible, and things like that. So anyway, have a look at these numbers now. It's interesting. Global wind installed power capacity is fast growing. So we have actually data before 2014 also, all the way from 2000, maybe 1990s, etc. So in 2014, the world wind installed capacity is 370 gigawatts. In 2015, it is 432 gigawatts, and later numbers are also should be available if you properly search. So due to lack of time, I could not search the latest one. So by the way, this is as of April 2017. So this video some might see after 5 years or whatever. So then the numbers will become very outdated. But anyway, just for but then it will be useful to have this. So that's why I'm mentioning the year in which this is recording is being made. Wind energy is about 4% of global electricity capacity. Okay, as of 2015, 83 countries are using wind energy. Good. So more countries should use wind energy. Denmark has 40% share of wind installed capacity. So Denmark is leading in that sense that they have this is the highest number. In fact, we have other countries also. So a list of shares of other countries also, we are going to look at it. So here I am saying refer to wiki page. In fact, that's exactly what I am going to do. So I will look at cumulative wind capacity, world electricity generation, all some details. Let's do that. So instead of copy pasting them here and all doing all that things, I thought I will directly show you the website itself. So you can also in your free time open this website. It's just Wikipedia. So go to Wikipedia, search for wind power, and you'll be able to get this information. So let's look at what we are having here. So just like a magazine, we only look at the pictures. So this is global wind power cumulative capacity. So what is a global wind power? So on y-axis we have cumulative capacity, that is in gigawatts. So here I say I'm seeing 432.4 gigawatt hours, and this is for the year of. So I think I have to zoom out a little bit. I think there's some problem. It is getting stuck. Let me just. Wind power. Okay, due to some reason, this website has stuck. Let me freshly make a search. Okay, so here it is. So so on x-axis you can see 1996, 97, 98 and so on. Up to 2015, the maximum wind power we are getting is 432. So gigawatt. So it is good to uh, have that number. So I'll move a little bit down. There are a lot of information given, history of wind power and so on is given, so you can read it. So large onshore wind farms. So onshore means on the land. So there is a Gansu wind farm in China, which is one single wind farm of 6,000 megawatts. So sometime back we had seen a picture that one tower is 10 megawatts. So I think this one. So the height of the tower itself is like 145 meters. It's very high. So if you look at even if you take 2 meters or 3 meters as the height of a one-story building, so just this diameter itself is like a 30-story building. So it is very very high, and this is 10 megawatts only. Now to make 6,000 megawatts, you require 600 such towers, huge towers like that you require. So this is one, this one. So maybe there is a picture of it. So you can see if I open the link, it's another Wikipedia page. So some kind of a small part of the huge turbine farm. So there's a picture here. You can see it's only a small part, and one single turbine is here. Okay, so let's get back here. The second largest is Uppandal wind farm, and that is in India. So the second largest onshore wind farm in the world is actually in India, and fourth largest is also in India. So, and whereas third one is in United States. So you can again have a look at it. So here also you can see there's a picture. So I'm not opening the picture. I just want to continue with this one. So that is this one. There are offshore wind plants also. So offshore wind plant looks something like this. So you in the water you set up this thing. So sometimes they are floating, sometimes they are fixed to the ground, fixed to the bed of the ocean, or sometimes they are simply floating. So these are slightly more costlier. So world's largest offshore wind farms are like this. So the London array is 630 megawatts. So whereas 576 and 504 and things like that. So here you see 175 turbines. Each turbine is 3.6 megawatt. So this is the configuration of the London array, largest offshore wind farm. So we might also get a picture of it. So maybe nothing clearly visible. Maybe you can, in your free time, you can have a look at it. So I actually like seeing, learning by pictures. So any new concept I have, so people didn't had this facility to do image search, but now we all can use that facility. You can go to Google and search for an image, and then you can see how it is, what it is, and all. So that's a very good thing, I feel. Now, wind power capacity and production. So, here you can see on the x-axis is the year 89, 90, all these things. In the year 2012, on the y-axis is the terawatt hour. So I think it is, so this line is 500. So each line is 10. So 520 terawatt hours in the year of 2012. So that is what is there in this picture. I think this is a more or less same information. So just remember that number. In 2012, we are able to generate 520 terawatt hours. Okay, so let me write it down. So that's what is the capacity calculation I wanted to show. So in 2012, 520 terawatt hours world has generated. All countries put together like this. But what was the capacity in 2012? So again, if I go back to this first picture, in the year 2012, the capacity was 282.8, or roughly 283. In 2012, 283 gigawatts. So from 283 gigawatts, I am getting 520 terawatt hour in 1 year. So we'll come to the calculation of capacity factor. It's the next topic as you see here. Anyway, let's continue with the pictures that are there here on this and the tables. Alright, top wind power, electric power producing countries in the year of 2012. So United States, Canada, Spain, Germany, India, all these things countries are there. So the top wind power producing is United States, followed by China, followed by Spain, Germany, and all. This was back in 2012, but I think by now 2017, China has overtaken United States in wind power production, and that you can actually see on the right, worldwide new installed capacity in the year 2014. If you look at only 2014, this red one is the capacity addition by China. So 23 gigawatts has been added by China, whereas US added only 4.8 or 5 gigawatts. So the growth is much faster for China compared to the other countries. So therefore China might have already overtaken. So this is in 2014. World cumulative capacity in 2014. So already you see this red one is China. So this is in the year of 2014 and this is cumulative. Also look at this penetration. So we'll come back to this. So there are some pictures. So a lot of pictures are there. So I strongly encourage you all to look at this. Yeah, so this is interesting. You see how they are transporting the blade of a wind turbine. Just to carry one blade of a wind turbine, there's a huge truck is there, and the truck is carrying this. So that such is the huge size of this turbine. So again, okay. So one final picture I would like to show you, that is at the bottom of this page. So many references are also there. So a lot of material is available. So yeah, this one. So here you can see they are in the process of, this is in Germany, Enercon E70-4 in Germany. So they are in the process of constructing the wind wind tower. So you see there is a small truck here, actually a big truck, but it looks very small compared to this. And then if you actually zoom and then look at it, you can see the sense of the size. And if you further zoom, you can see at the tip of this, you can see two people standing here. So this the tip of the blade, there are two people standing, and look at the size of the blade here, and then it is going to go so high here, and then it's going to generate wind energy. So just I wanted to give you the sense of size of this particular thing. So these are all houses you can see here, all that. Anyway, let's get back to our this thing. So there are only small things I would like to conclude. So one is the capacity factor. So wind flow is not constant. So energy production is not equal to the capacity of the wind plant multiplied by hours of operation. So if the hours of operation is 10 and wind capacity is 1 megawatt, like I said, it will not generate 10 megawatt hour. Capacity factor divided ratio of actual energy generated to theoretical maximum. So in 2012, as we have seen, 282.2 gigawatt was the wind energy generated. Sorry, is the installed capacity, and 520 terawatt hours was the wind energy generated. So what we have done is capacity factor is actual energy generated is 520 terawatt hour. So divided by 282.2 gigawatts into 365 into 24 hours. Now gigawatt hours. So if I multiply, sorry, if I multiply numerator by 1000, tera into 1000, like tera divide, actually to convert a figure in tera into giga, you have to multiply by 1000. Then this 1000 I can just cancel all this. So the units are all cancelled. So 520 into 1000 divided by this everything. So this comes out to be 0.21 or 21% utilization. So the worldwide utilization capacity factor or capacity utilization factor of wind power is only 21%. So it is usually between 15 to 50%. So right now it is 21%, and the target is to get 40 to 50% of capacity utilization. So improvements in technology, proper selection of the site, etc., will result in higher capacity factor. So these are the things. Now again, compared to nuclear, the capacity factor is almost 95%, because nuclear power, once you start it, it keeps on running for 10 years or 15 years or whatever. It will not stop. It is all the time. It is continuously running, and throughout the year, 24 hours, 365 days, you generate the power. So the capacity factor is very high for this. Similarly, for thermal power plant also, almost 90 to 95%. But coming to wind, it is only 21%. That is one of the disadvantages. Similarly, capacity factor for solar power for PV photovoltaic also is less, because, of course, there is no sun in the night time. When the sun sets, there is no sunlight, so there is no solar power generation. So that's the thing. Now, a small discussion about wind energy penetration. So, what is the meaning of this term penetration of wind energy? Is the fraction of wind energy to the total electricity. So, worldwide, the wind energy penetration is only 4%. So, 4% of total energy is actually coming from wind. As this increases, we call that increase in the wind energy penetration. So factors affecting maximum wind energy penetration: configuration of existing plants, pricing of wind power, storage capacity available. So if a lot of storage capacity is available, then you can actually welcome more wind power into the grid. Connectivity of transmission grid for evacuation. So connectivity is also important. Coming to connectivity, like here I said capacity factor. So imagine that there is a wind farm here. Not only one, there is a lot of this thing, and then there is a long transmission line, and at the receiving end of the transmission line there is a city, and the city is consuming the wind power, whatever is generated. Now the problem is, what is the capacity of this transmission line? So let's say this distance is about 50 kilometers or 100 kilometers. What is the capacity of the transmission line? So if the capacity of this is, let's say, 1000 megawatt. So I've shown you like one tower is 10 megawatts. So there are 100 towers here in this small island, and 1000 megawatt is being generated. But this 1000 megawatt is only the peak power. So throughout the year, actually, how much you are able to generate is only 20% utilization factor. So, but anyway, the transmission line has to be again 1000 megawatt transmission line, 100 kilometer 1000 megawatt transmission line. But ultimately, how much is the energy that this is transporting? This is transporting only 21% of energy to the city. So, so the entire economics of this wind power will depend on this now the economics of this transmission line. So earlier the transmission line was used to run at the full capacity, and therefore it used to get the investment back very quickly. But now because of this huge distance, it has become a challenge now. So although the technology, everything may be available at this level, because of just the sheer economics of this 100-kilometer distance transmission line, the project may become infeasible. So that is the problem. So that's what I am meaning. Connectivity to the grid for the evacuation of the power. Because capacity utilization is less, so the evacuation is a difficulty. So how do you address that? You have solar power here. So wind and solar are complementary, so that you can, same line can be used by solar, so you can do that. You can have some other alternate forms of energy sharing the transmission line, thereby reducing the cost or whatever. So these kind of strategies you have to use. Smart control techniques, reserve capacity availability, and demand response schemes. So these are the factors. Now 20% is not difficult. See, right now the world is at 4%, but we can go up to 20%. But more than 20% will create technical and economical problems due to variations and all these things. Major research area. So how to increase uh, the how to increase the penetration of wind energy is again a research area. So those of you who are interested in not only this wind but renewable energy itself is a huge research area. There are hundreds or even thousands of researchers around the world working on this problem. So you can also become one of them. You can actually join them and then participate in this very exciting research area in this field, that is renewable energy. And system operating cost increase with increasing the wind penetration. So obviously, because the more wind penetration is there, the more variations will be there. The more variation is there, the more system operation you have to do, and therefore the cost increases and so on. So that's about wind energy penetration. Let me see if I have any other topic. Maybe this I'll take up in the next video. That is little comments about what is the economics of wind power. So in this video, in the part one, I had tried to introduce you to this wind energy system. One of the major, in fact, this is the major after hydro. This is the major real renewable energy source. See, hydropower is anyway, it was there since last few decades, and hydropower is renewable energy. But then coming to the modern renewable energy sources, wind is the first one, and wind has the highest capacity installation in the world. So I think we had seen that figure somewhere in this, that is close to 32 gigawatts. So here you can see 432. I'm sorry, I'm remembering for one country, but 432 gigawatts of wind energy is there in the year of. So by the way, do you know in 2017 what is the total all renewables put together? I think it's somewhere close to 800 gigawatts. So this is all renewables put together, out of which already 432. I think this might have reached close to 500. So 500 is wind. So, in fact, I think that we already discussed in the initial video of this playlist. Anyway, so with this brief introduction, let me let's take a break here. Let's join in another video and we'll see more about wind energy. Thank you.